Hello students, this playlist is dedicated to integration, and in this lecture we will be learning about indefinite integration. Indefinite integration is what you call the opposite of differentiation without any limits. So integration in general is the opposite of differentiation. So let's try to decode its formula first. So in differentiation we had this formula that d by dx of x to the power n. If you have, what you did was first n came forward and then you had x to the power n minus 1. So the steps that you followed were you first multiplied the power, and then what you did was you subtracted 1 from the old power, right? So you multiplied the old power and then you subtracted minus 1. So as we started this lecture, we said that integration is the opposite of differentiation. It is applied when you undo differentiation. Like to undo a positive sign, you have introduced a negative sign. The same for the negative one. If you want to undo a negative or subtraction operation, you add. And similarly, if you want to go to the opposite of multiplication, then you divide. So the opposite of differentiation is integration. So what will we do? So in order to integrate, your steps for integration would be see, you will go backwards. So initially the second step was to subtract 1 from the power, right? So what will you do? You will add 1 because you are going back. And then the next one was you multiplied the old power. So what will you do? The opposite of multiplication is division. So you will divide the power, but this time it won't be the old one, it will be the new power. So that gives us the formula for indefinite integration. So here is the formula. So for integration, what you need to keep in mind is that integration has a special sign, just like how we did in differentiation. In differentiation, if we had y is equals to x to the power n, then this was dy by dx. Similarly, just like how d by dx here was the notation for differentiation, the notation for integration is this elongated s. You know how to write s. You will stretch this portion, this middle portion of s, and you will write it like this. So this elongated s in here and along with this dx is the symbol for integration. Just like how we saw previously that dx meant differentiation. If we had d by dx, then it would refer to differentiation with respect to x, right? Because we had x in here. Similarly, if we see x in this side, it would mean integration. Because of this sign now, it means integration. So it means integration with respect to x. If we had this integration symbol and a dy in here, if we have integration symbol and a dy in here, then it would mean integration with respect to y. If we have an x in here instead of y, it would mean integration with respect to x. Now see that this here is called integrand. Whatever you're integrating is called integrand. And this here, the result of integration is called integral. Previously, we saw that whenever we differentiated, the result was called derivative. The result of differentiation was called derivative. Result of differentiation was called derivative. The result of integration is called integral. So, what is the formula we just saw? That the formula for integration was you first have to add 1 and then you divide the new power. So when you add 1, so if you have x to the power n, so for integration, what do we need to do? We have to add 1 first and then we divide with the new power. Our new power is now n plus 1. The old power was n, the new power was n plus 1. So this is our rule for integration. This is the rule for integration. That you add 1 to the old power and then you divide by the new power. Add 1 and then divide the new power. Similarly, we saw in chain rule, when we did chain rule in differentiation, when you had, let's say, 5x plus 3 to the power of 2 in differentiation, what did we do? You subtracted 1 and then you multiplied with the coefficient and the power. You first multiplied the power in here. We saw PFA. For chain rule, we first multiplied power, we dealt with power, and then you differentiated function, and then whatever was in here, the coefficient of x, you multiplied with that. So the same thing will happen here in the chain rule for integration. If you have ax plus b to the power of n, you will add 1, you will first deal with power. Similarly, you will first deal with power. So what will you do? You will write n plus 1 and then divided by n plus 1, as usual how you deal with power, and then you see the function. In the function you have the coefficient a, so you divide by a. Previously in differentiation you multiplied, integration is the opposite, so you will divide. It is not very difficult to understand this one. Now the complicated part here is this portion plus c in both of the formula. Now why will we add plus c? So c here stands for constant. C here means a constant. Now why do we add a constant? Because we know that integration is the opposite of differentiation, and whenever we differentiate a constant we get a 0. So because if you have nothing in here, it means you have a 0. So when you integrate this, you are supposed to get a c. It is very easy to see that whether this formula works or not. It is given in here. See, if you have x to the power n, remember that this n here can be a positive number, a negative number, or a fraction as well. There is no restriction in the value of powers or n in here. See how the integral comes from this function in here. So when you differentiate this, you know the formula for differentiation gives us -1. You first need to multiply with the power. So when you multiply with the old power, let me write it here. So we know that for differentiation, you multiply the power first and then you subtract the power, right? So this was what was given to us. And then for plus c, when you differentiate a constant, you get 0. So this n plus 1 and n plus 1 gets cancelled out. This plus 1 minus 1 gets cancelled out, and you get x to the power n as given in here. So this means that this integral is actually the integral for this function. It works. We have differentiated this and saw that this actually comes as the function. Similarly, here is the other formula that we saw, and if you differentiate ax plus c, you get a. Then again, if you want to use the formula for integration to check whether the third one is correct or not, you can use it. See, if you have nothing with a, then it means that you have a x to the power 0, because x to the power 0 gives us 1. So according to the formula, you will have a is a constant, so it will stay as it is. Just like in differentiation, coefficient doesn't play any role here. So we will have x to the power 0 plus 1 divided by 0 plus 1, and then we will have a plus c in here. So this gives us a x to the power 1 by 1 plus c. So we don't write the power of 1, so we write ax plus c. So this gives us the formula in here. We will deal with trigonometric and exponential integrals later on. We will see this integration in a different lecture, in the next lecture. So in today's lecture, we will only focus on the algebraic integration, the indefinite integration for algebraic expressions is our topic of concern in this lecture. I hope the formula is clear. It is just like differentiation. If you remember differentiation, we saw in differentiation that if we have a constant, then the differentiation is 0. So definitely, if the function is 0, then the integration would be a constant. If the function is 0, then its integration is a constant. Integral is a constant. If you have a constant, then its integration would be ax, because when you differentiate ax, you are supposed to get a. So these three formulas you will memorize. Then we have x to the power n, which is the very basic one. You know, it comes from the opposite of differentiation. You add 1 to the new power and then you divide by the new power. The same goes for this chain rule of integration. In integration, you do not have any product or quotient rule like you had in differentiation. So that saves us a lot of trouble and makes the sums easier. In IGCSE, we are only concerned with the basics. So let's see what we have in here as an example. We have this sum where you have dx in here. So dx means that we have to integrate with respect to x. That means we are only concerned with x. All other letters that we will have will be variable, including y. So we see that we have p in here, but p is a constant and we are not concerned with p in this case. Now, with all of this, you have x multiplied, and we know there is no product rule for integration. So you have to convert everything to simple expression first. How do you do that? You multiply x with all of these terms in here. So you are supposed to get integration of x squared into x. So you have x squared multiplied with x. Then you will have x to the power of minus half multiplied with x. Then you will have x to the power of 3 by 2 multiplied with x. Then you will have 4 multiplied with x. And lastly, you will have minus p multiplied with x, and you have a dx in here. So x squared into x will give us x cube, plus we have x to the power of minus half into x. Now x to the power of minus half into x means what? X to the power of minus half into x to the power of 1. And we know from the rule of indices that if you multiply two terms of this same kind, what happens to the powers? The powers get added up. So minus half plus 1 gives you x to the power of half. Then we will have, in the same way, we have x to the power of 1 in here. So we know you have x to the power 3 by 2 into or multiplied with x to the power of 1, which means the powers will get added up. So we will have x to the power 3 by 2 plus 1, which is 5 by 2. Then 4 into x is 4x, minus p into x is px, and we have a dx in here. Now, because we are simplifying whatever is in the inside or in between this integration sign and dx. We are not integrating yet. We have not done any integration yet. So we will not remove the signs. These two will only get removed when we have completed our integration. So in the next step, we will be focusing on integration. We are starting the integration, so we do not need this. In the first two steps, the one with this purple ink and the one with this green ink, in these two steps, we did not integrate. And because we did not integrate, we are not removing these two signs. We have kept them. In the third step, I am integrating. So now I will remove these two signs. So x cube, we know the formula is adding 1 and then dividing by the new power. The formula is adding 1 and then dividing by the new power. The formula is, we are done with this one, we are done with this one. Now this one, the formula would be adding 1 and then dividing by the new power. For 4x, we will be adding 1. Again, if you have nothing in here, then it means that the power is 1, right? And in here also, if you have nothing over, then it means the power is 1. So 1 plus 1 and then dividing by the new power. Then minus px and then 1 plus 1, then dividing by the new power. And lastly, because we have removed these two and we do not know if there was any constant or not, we will always assume that there is always a plus 0 with it. So for plus 0, we will get a C. So this gives us x to the power of 3 plus 1, 4 by 4 plus x to the power half plus 1 is 3 by 2 divided by 3 by 2. Then we will have minus x to the power 5 by 2 plus 1, which would be 7 by 2 divided by 7 by 2. Then we will have 4x square by 2 and then px square by 2 plus c. We are done with integration. Now all we will have to do is we need to simplify. So for simplification, we have 1 by 4 x to the power 4 as it is. We know if you have nothing in the coefficient in here, then it means you have 1. So if you use your calculator, you put 1 divided by 3 by 2. In the calculator, you put 1 divided by 3 by 2. Please use this format to avoid any errors. What will you get? You will get 2 by 3 x to the power 3 by 2. Then you have, in the same manner, you have 1 in here. So you will put 1 divided by 7 by 2 in your calculator. You will put 1 divided by 7 by 2 in your calculator. And you're supposed to get 2 by 7 x to the power of 7 by 2. Then 4 and 2 gets cancelled out. 4 divided by 2, if you put in your calculator, you will get 2x square. And then you have half x square plus c. Now for 3 by 2 and 7 by 2, you know for both of these, you can write it in a nice power format, power with roots, because you have half in here. You know for powers like this, where you have the format of a to the power m by n, you can write this as nth root of a to the power of m. So you are going to follow that format. It makes the sum look neat. So we will be doing that. We have 2 by 3 x to the power of 3 by 2 means what? You have a 2 in here, which means this is the root. We know this is the power and this is the root. So we will be writing a square root of x cube and then minus 2 by 7, a square root of x to the power of 7. Then you will have 2x square minus half px square plus c, and this is our answer. Let's check out the next one. In here, we have this complicated fraction as the sum that we need to, or the expression that we need to integrate. So what will we do in here? We know that there is no quotient rule formula. So what will we do? We will write this neatly by simplifying it first. So when we simplify, we know that we are simplifying it first. We are not integrating. So this sign and this dx will remain. So we know we can write this as 8x to the power of 4 divided by 4x square, then plus 2x square divided by 4x square, and then we will have plus 1 divided by 4x square dx. So this can be simplified to 8 by 4. We know this can be written as 2, and then we have x square and x to the power of 4. So here the power of 2 will stay. For 2 and 4, we know 2 will stay in the denominator and x square will get cancelled out. So we have 2x square in here. From the next term, we have half only, because this 2 is in the denominator. So if you have nothing in the numerator, you have 1. So you have 1 by 2, half only, x squares get cancelled out. And in here, we know that the formula that we have for integration, that's integration of x to the power of n dx. So we know that in the formula, x is always in the numerator. X is not in the denominator. So because x is not in the denominator, we have to take this x square in the numerator. And if we take this x square in the numerator, what happens? We know that the power becomes a negative 1. So we will have to write plus 1 by 4 x to the power of minus 2 dx. Now we are all set for integration, right? Because now everything is simplified. We don't have to worry about any expressions of x, because it is dx in here, which means we have to integrate x. So x that we see here is all in the numerator. We can apply the formula directly. So because now we will be integrating, we don't need this integration sign and this dx anymore. We can start integration right away. So we have 2x to the power. We know we add power with 1 and then we divide by the new power. Then if we have a constant, we only write x to it, because we know if you have nothing in here, then it means you have x to the power of 0. We have just seen the formula for constant. You just multiply with the x. And then we will have 1 by 4 x to the power of minus 2 plus 1 divided by minus 2 plus 1. And lastly, because of this plus 0 in here, if you have nothing in here, we get a plus c. So we are done with integration. All we are left now is to simplify. So if we simplify, what do we get? We have 2x cube divided by 2 plus 1 is 3 in here, then plus half x, and then we have 1 by 4 multiplied with x to the power of minus 2 plus 1 is minus 1 divided by minus 2 plus 1 is minus 1 again, and we have a plus c in here. So we get 2 by 3 x cube plus half x, then 1 by 4 into negative 1, which gives us negative 1 by 4, and then you have x to the power of minus 1 plus c. Now x to the power of minus 1. If you want to make this power positive, what will you do? You will take this in the denominator, right? So you are going to get 2 by 3 x cube plus half x, then 1 by 4x plus c. And this will be your final simplified answer. Let's take a look at the other example that we have in here. So here you see that you have an expression that needs to be squared. But the formula for integration that we have, the basic integration formula, we have seen two formulas for integration. One of them is this, where you have x to the power of n dx, and the other one is integration of ax plus b to the power of n dx. See that in this basic one, there is no external power, but this one doesn't really coincide with this one. This doesn't look like this, right? So we cannot use this formula. And if we want to use this formula, see, in this formula you only have one x. You have an ax term and there is this other constant term. But here both of your terms are in x. So what will you do? Because you know the formula for square, you will use that formula. You know the formula for a plus b whole square. We know it's a square plus 2ab plus b square. So we are going to use this formula and apply it in here. So if we apply, what will we get? Because we are not integrating yet, the integration sign and the dx sign remains. And this one is our a, this one is our b. So a square plus 2ab plus b square. So what does this give us? Integration of root x square. We know that the square and the roots get cancelled out. So we will only be left with x in here. Then we have plus 2 into 2, 4. This root x is in the numerator, so root x. And then you have x in the denominator. Then you have plus. This square is over both 2 and root x because it's over in the bracket. So whatever is inside, both of them will get squared. So 2 square is 4 divided by x square. Let me write it by breaking it down. So we will have 2 square and x square. And lastly, we will have a dx in here. So what do we get? So what we are supposed to get is integration of x plus, because we cannot integrate yet, that's why I am not removing this integration and the dx sign. We need to simplify these and these first. So root over x can be written as 4x to the power of half, and then you have divided by x plus you have 4 divided by x square dx. Now you have x to the power of half divided by x to the power of 1, because if you have nothing in here, it means that your power is 1. So we know that for division what happens? The powers get subtracted, right? So we will have x to the power of half minus 1. So we will apply that in here and we will get integration of x plus 4x to the power of half minus 1 gives you x to the power of minus half. So we will have 4x to the power of minus half plus, we need to bring this x square in the numerator. So we will get 4x to the power of minus 2 and then dx in here. Now all the x that we are concerned about, because we have a dx in here, are in the numerator and we can start integration. Because we are integrating, we do not need to write this sign and dx anymore. So for this one, we will have x to the power of, if you have nothing in here, then it means the power is 1. So 1 plus 1 divided by the new power, then plus 4x to the power of minus half was already in there. So you add plus 1, then you have minus half plus 1. And in here you will get 4x to the power of minus 2 previously was given. So plus 1 divided by the new power. And lastly, because of a constant that we consider plus 0 to be in here, we will get a c. So when we simplify, we get x to the power of 2 divided by 2 plus 4x to the power of minus half plus 1 minus half plus 1 is going to give you half divided by half, plus here again you will have 4x to the power of minus 2 plus 1, which is minus 1 divided by minus 1 plus c. So your final simplification would be half x square plus 4 divided by half is, for this you're going to put 4 divided by half in your calculator for this part, and the calculator is going to give you 8, and then you have x to the power of half, and then 4 divided by minus 1, you will put 4 divided by minus 1 in the calculator for these two, and you're going to get minus 4 x to the power of minus 1 plus c. So when you simplify, your final answer would be half x square plus 8. Because of x to the power of half, we know x to the power of half means root over x. Then x to the power of minus 1 would mean minus 4 by x, and lastly plus c. So this is your final answer. Let's take a look at the next one. In this sum, what we have is integration of 2 and then 5x minus 6 to the power of 4. So this form that we have here resonates with this one, where we had ax plus b to the power of n dx. You have a expression where over the whole expression there is a power. See, over the whole expression there is a power in here, and there is only one term with x, the other term is constant. There, over the whole expression there is a power, there is only one term in x, and there is one term which is constant. This coefficient here 2 is the coefficient with the entire thing, so we know that this will not be a part of the integration. So we can apply the formula directly. What does the formula say to us? The formula is, again, because we are integrating right away, we do not need this and this. So 2 will stay as it is. It's a coefficient. It stays there. Now for this part, we are going to use the formula. The formula says, just like how we have done integration in the previous ones, the power will be added to 1. So this is your power part. You're done. And whatever is the coefficient of x, whatever you will have in the coefficient, this is the coefficient of x for now, 5. So you will multiply the coefficient. So with this, you will multiply the coefficient. And because we know we have plus 0, always we think it like that. So you'll put plus c. Now when you simplify, what do you get? You get 2 5x minus 6 to the power 4 plus 1, which is 5, divided by 4 plus 1 again is 5 into 5 plus c. So our final simplification would be 2 divided by 5 into 5, which is 2 by 25, 5x minus 6 to the power of 5 plus c. Let's try to take a look at the next one. In here, we have integration of 3 divided by root over 5 minus 4x to the power of 3. Now, in here, we can see that we have a fractional part where we have power over the entire thing. So what we can do is we can first take everything to the numerator, because the formula that we have seen just now, the ax plus b to the power of n formula, this formula has everything in the numerator. There is nothing in the denominator, right? There is nothing in the denominator. Everything is in the numerator. So we must convert these to power and take it to the numerator before integrating. So let's simplify it first. So if we simplify, 3 will remain in its place. In the numerator, we have root over of 5 minus 4x whole cube. So we know that we can write this as 5 minus 4x to the power of 3 by 2. We have square root. We have seen that a to the power of m by n is from nth root of a to the power of m. So in place of m, we have 3, and nth root means square root in here. So that should be 3 by 2. And then dx will stay as it is. So now we have to take this in the numerator for integration. And because we have not started integration yet, we will keep this integration and the dx in here. And we will write 3, 5 minus 4x to the power of negative 3 by 2. Why negative? Because we are taking this in the numerator. If we want to take this in the numerator, the power will become negative. Now we have started our integration. In this third line, we will start our integration. So we don't need this or this. So 3 will stay as it is. And for this part, we know that we first have to add 1 to the power. So minus 3 by 2 plus 1. And then we divide it. The very basic rule that we have, we first apply that. And then we see that for the next part, whatever is with x, we multiply that. So we have minus 4 as the coefficient of x and we multiplied it. So what will we get in here? After we simplify, will be our answer. So when we simplify, what do we get? We have to write plus c, obviously. So we are going to get 3, 5 minus 4x to the power of negative 3 by 2 plus 1 is negative half from our calculator, divided by negative half into negative 4 plus c. So we have 3, 5 minus 4x to the power of negative half divided by minus half into minus 4 from our calculator gives us positive 2, and we have plus c in here. Now we have 3 by 2. We know that this negative half, if it comes down, we have to write it by simplifying it as much as possible. So if this negative needs to be removed, then it will come down in the denominator. So it will be 5 minus 4x to the power of half. Now, to this power of half can be written in terms of root as 3 by 2 root over 5 minus 4x. And then this plus c remains. So this is how we do indefinite integration in algebraic expressions. With this, we are done with today's lecture. In the next lecture, we will be dealing with trigonometric and exponential expressions. Stay tuned for the next one.